Well, good morning and good afternoon, everybody. My name is Lynne Strickland, and I'm with the Canadian Home Builders Association, and I'm with the Net Zero Housing team. And this is part of our webinar series from the Towards Net Zero Renovations. We've been working with Building Knowledge Canada and our project teams from across Canada to contribute to this. So we're going to kick off with the ventilation and indoor air quality, improving your indoor environment. This is a key and very close to home for me. I started off as an environmental scientist and an indoor air quality investigator. So where things go wrong was how I started in the construction and in the built environment business. So scenes like this, where you're looking at, what's behind the walls, tie in very critically to what we're going to be talking about today. So a few housekeeping notes. So the question and answers are the ones that are going to be addressed by our speakers and panelists and our renovators and energy advisors. So please put those in the question and answer, and then the chat, please feel free to engage with your colleagues from across Canada who are attending. Make sure that you're thoughtful and considerate in all communication. We will have a Survey Monkey just before the question and answer, so we'll hope that you fill that out to help inform webinars in the future. And we will be sending out the link. You're already probably, if you've signed up, you saw the recordings from the previous videos on our CHBA website, and we'll be posting there along with the decks as they get finalized. So ventilation and indoor air quality. Why is this such a critical one that it showed up on the top 5 of the top 12 topics that Building Knowledge Canada and CHBA wanted to do webinars on through this Towards Net Zero Reno? The reason why is that there is a lot of communication about improving the existing building stock, about improving energy, doing energy upgrades. But this is where we talk about what's the impact on the occupant. And that is what differentiates a lot of our work. So you see here, these are the participating municipalities. So we've got information from across Canada, whether from Wakmushtu to the Yukon and all of our 100-kilometer border population. And what we look at through all those municipalities and through our project teams is what sets a CHBA Net Zero project apart is the due diligence and the thought of the occupant as equal consideration to the envelope, because they interact in that integrated design just as much as the different components of the house itself. So this is where an EnerGuide Zero is a fantastic achievement. What we want and what we have learned through this project is that that alone isn't enough to drive what the work is in terms of upgrading our assets to a net zero solution or towards a net zero solution. What is driving is often those non-energy drivers, and many of them are related to what we're going to be talking about today in terms of ventilation and indoor air quality. So this is the team behind the scenes. BKC has been with us since 2022 from the very onset of this project and have guided a lot of our building science and also that feedback from industry. We leverage everything that we can to make sure that we're on point and bringing to you what is needed most. And to that end, what we've developed, if this is your first webinar or your 4th webinar, we have worked with our Net Zero Advisory Group. And we've also worked with our participating municipalities, our home builders associations, but obviously as well as all of our project teams across Canada to bring you these webinars. We're in the ventilation, so we have one more left with the January session on windows and getting that retrofit aspect, which is always challenging in existing housing. So please join us on January 14th. You can find all of those webinars at this QR code. So let's bring you to the team. So again, my name is Lynne Strickland. I'm the Director of Net Zero Initiatives with CHBA. We have Mark Rosen, who is going to be the lead subject matter expert and lead facilitator on this webinar. We have Jérémie Legere from the LEEP team, the Local Energy Efficiency Partnership team from NRCan. And again, a vast amount of resources there. Mark Bernhardt from BC, who is bringing a perspective as an IDP facilitator navigating LEEP 10, which is 10 houses at once, self-aggregated, which means they don't come all as a package, they're all independent, but also brings a real strength in those aspects of the diagnostics. And then we have two of our renovator teams led by Michael Shaw and Luke Vandenbosch, who are going to tell you what it is like to put it in practice. And that voice from the ground is really critical, where we move from theory to reality, and then we have the application of how that works. So you'll hear more about Mark Rosen. I'll be turning over to Mark shortly. Mark has also been leading in terms of coming from Vancouver and giving that perspective and working in Ontario and across Canada and giving that insight, and has been a guiding help throughout these webinars as well. Jérémie Legere, as I mentioned, comes from the LEEP team. There, I've included this link to the resource page because the LEEP team has a lot of amazing resources and guides out there for all of us to leverage. And Mark Bernhardt, as I mentioned, has been integral in our net zero family for quite a while, is a KC integrated design IDP facilitator, qualified, but also has been a long-standing net zero along with Mark Rosen as a net zero energy advisor, and have really been integral into our net zero home labeling program development. And then we have our project teams. So on each of these projects, we assigned a mandatory requirement that a qualified net zero energy advisor had to be on every single project. So for Michael Shaw's project, Centennial Kitchen Bath out of Saskatoon, Darcy Buzdell from Sunridge was the net zero EA. And for Luke's project, V+V Homes out of Thorndale, off London area, we have Jason Chang from HomeSol, who was the net zero EA. And we also have on call Toby Smith, who has also been with this project since 2022 as our master energy advisor and also energy advisor program manager for this project. So he's been the point of contact for all of our energy advisors throughout the past several years. He'll be answering questions in the Q&A that he can, and he'll be saving some ones for the group. So Kimberly, I'm going to turn it over to you now to do the poll. So that's us. And so we want to find out a bit about you. And so we'll find out where you're from and what your profession is. So we'll start off with, where are you located? We're hoping that we get some territories. We'll give it a few more seconds. All right, Kimberly, let's see where we've got. Okay, a strong, okay, we've got Manitoba. Manitoba, you are hunkered down in a blizzard. Thank you for joining us. I'm glad you have connection. It is nasty out there. We've got Quebec, Atlantic, Saskatchewan, Alberta, BC. You know, we'll try for, oh, and we have a few from the US. That's welcome. Thank you so much for joining. All right, we'll move over to occupations. One of the things that we found through the Towards Net Zero Reno is that although we have primaries like energy advisors and the renovators, this involves so many. It is such, the reason why I have repeated the integrated design process is that to get it right, you really do need to have that network of trusted contractors and trusted consultants to bring the right solution for your client. So I'm hoping that we've got a good representation from all of that spread. And the estimator is a key one, because that's something that's getting asked all the time, is how much does this cost to move our housing stock towards net zero? And when we talk about towards net zero, I do want to clarify in this webinar that that is a key point, is that we have been trying to move the dial towards it, keeping it on a roadmap, so that there isn't sunken costs that then have to be undone, such as adding lots of attic insulation and then realizing you didn't do an air barrier and having to pull that all back. So it's really getting on that path of getting us towards that without necessarily going all the way to a labeled home. So we've got renovators, engineers, architects. Mark Rosen, you'll be happy with that. We've got energy advisors. Oh, great. Site supervisors. Love that. Estimator. Great. All right. Thank you so much, everybody. Really appreciate your input on that. nice to know who we're talking to. So at this point, this is where I turn it over to Mark Rosen, and we're going to be digging in with the subject matter experts that you see on the screen to get into that building science. Mark, over to you.
Thank you very much, Lynn, and good morning, good afternoon to everybody on the call. Thank you for your responses in the poll. Really interesting to see in the occupations. A lot of people put in the chat building official, so welcome to the building official people tuning in as well. Great to have you here. I have the honor of being the first of the subject matter experts, but by no means does that put me, in a better position to speak to this topic than Jérémie and Mark, who will follow as well. But my role for today is really to set some context about ventilation as a building science principle, what makes it important in our homes, and what the strategies and pieces of equipment involved in really having an effective ventilation and indoor air quality strategy are, to set the stage for some discussion about how that works in renovation projects and some really great examples from the renovators that are on our call today. So let's make sure that my control is working. I'm going the wrong way. Let's see here. There we go. Excellent. We are in business. Okay. Topics for discussion today. We're going to have a quick refresher about some of the history around ventilation and indoor air quality. It's really refreshing and encouraging to hear about what a leader in this space Canada has been over the last decades and century. Really, a lot of the innovation and research around this topic comes right from at home here in Canada. We will talk about strategies for improving and maintaining indoor air quality, the options that you have for ventilation strategies, some key discussion about what the heck is the difference between an HRV and an ERV anyways, and which of them makes the most sense for me. What is the equipment and the strategy of choice when you are approaching a renovation and on that towards net zero renovation pathway? So when we talk about ventilation, you often hear ventilation paired with these terms IAQ or potentially and more frequently nowadays IEQ. So let's define some acronyms before we start to throw them at you and add to your cognitive load. IAQ is short for indoor air quality. And the key term here is we are concerned about the air. Air contains within it relative humidity, mix of gases that affect us. Some of them are good for us, some of them not so good for us, and can also contain airborne particles, particulates like mold or dust or other things that will affect our health in various ways. But when we talk about IEQ, which stands for indoor environmental quality, we're extending that definition to also consider some of the aspects of our homes that influence our health and comfort that aren't specifically related to the air. And this includes air temperature necessarily, but it also includes things like surface temperatures, the access to natural light that you have, and even the sound quality that has an impact on us as humans and affects our experience of a home and our space. Now, because air is such a big piece of both IAQ and IEQ, ventilation is the topic space, if you will, when you're talking about mechanical systems that most directly has an impact on IAQ and IEQ and is, let's say, it's an essential component. You really can't talk about IEQ solutions without talking about ventilation at the heart of it. There has been a lot of important research, as I said, within Canada over the decades about the importance of this. And you will get access to these slides after the fact. So I invite you to come back to these studies that are highlighted here and maybe go and look at them in more depth. Suffice it to say that we understood very early on that it would be important to understand the role that indoor air quality plays in our health, and therefore understand how we can affect that and direct that in our codes and programs and requirements. Some of the key findings of the research are shown on this slide. I'd like to highlight a few of them. The first one is really eye-opening, and that is that the indoor air quality of our older homes is sometimes as bad as 2 to 5 times worse than the air quality outside of our homes. And that applies even in cities. And we know that inside of our homes is where we spend the great majority of our time. And so improving on that statistic is a very, very critical thing. We also know that things like mold growth are more heavily influenced by things like bulk moisture and air leakage more than they are by relative humidity. And so One of the things we'll touch on several times today is that interconnection between air tightness and the importance of ventilation in managing things like bulk moisture before we ever even start to be worried about relative humidity in our homes. We can only get to relative humidity once we've got everything else right in the beginning. Another very important highlight from the research that we found further down on this list, leaky houses have more mold and moisture issues than tight houses. And so again, understanding that we want to build as airtight as we possibly can, but that when we do that, we trigger this connection to ventilation. This importance of build tight, ventilate right can't be understated. It's not one or the other, it's both and we're going to talk about why that's really matters. So what is good indoor air? How do we know what is the benchmark that we're measuring to when we say good indoor air? The ideal here is that we're trying to have air in the house that is as clean as outdoor air, or I would suggest sometimes even cleaner than outdoor air. When we're talking about what's outside of our houses, we have no control over that. But inside of our homes, if we get the ventilation strategy right, we can filter the air, we can control the relative humidity, we can control the temperature, and we have an opportunity to make it the healthiest air that we have access to in our day-to-day lives. A really good indicator of the quality of your air is your nose. If you can smell anything, that means there is something in the air. And that doesn't necessarily have to be a bad smell. Even good smells point to airborne contaminants that may have an impact on our health. Think, Glade Fresh plugins and the things that make your house smell like fresh new car, etc. Those are actually, by the definition, contaminants in your fresh air supply. So we're looking for air that has fewer pollutants, is therefore healthier to breathe, and of course is at the right temperature to maintain our bodies and our homes and the right humidity alongside that. We know this is important. I don't have to really dwell on the stats that scare you on this slide, but the frequency and severity of asthma has been on the rise historically as houses got tighter without understanding the risks associated with underventilating. And the health impacts of poor indoor air quality results in massive amounts of healthcare spending, a big load on our healthcare system, and importantly, it affects us and our children in our homes, which hits close to home. And I think many of you may know somebody or have somebody in your family that's affected by health issues related to indoor air quality. The air cleaning industry has benefited from this by selling us these freestanding pieces of kit that we love the look of and we want to put front and center in our living room. But as we move towards net zero renovations, we have an opportunity to do this invisibly and better and make this a better experience for the homeowners than just relying on the one piece of equipment in the one room that's doing its job. Why is this a bigger issue than ever? Have our homes gotten worse? What is it about this move to, through the decades that has made IAQ an issue where maybe it wasn't before or wasn't understood to be an issue before? Well, one of the things that's changed is we've changed the way we build. We are building better homes than ever before. Even new homes that are built just to the minimum requirements of code are some of the best houses in the world. We have very high standards of housing in Canada. But we are building them tighter and with more manufactured products, which means that we have more things to deal with in terms of off-gassing and contaminants that can build up inside of our homes over time. We're also changing the way we live. We spend collectively much more time indoors with closed windows, which can lead to higher moisture loads and, again, more of a buildup of the contaminants in our air. And this is potentially exacerbated by changing the products that we use. We're getting better chemically at inventing things that are useful to us in our day-to-day lives, but not all of these things are necessarily good for us to be breathing in. So we want to learn to deal with them. When it comes to strategies for dealing with these contaminants to our indoor air, the very first and most important thing that we can do is to remove the source of the contaminant itself. And so when you're talking about household products that you're buying and putting in your cupboard or in your garage, if you can smell it, the best thing you can do is to get rid of it. That's not always an option because sometimes they're built into our homes or they're things that we do need to keep around. So the next best thing we can do is to isolate it. This comes in with, let's say, take a sump pit, for example. If there's a smell associated with your sump pit and you can put a sealed cover on your sump pit to isolate that and have source control, that can be a huge part of the strategy of improving the air quality around in your basement as a result. But third, and the topic of our discussion today, is ventilate. Once you have done what you can to remove the most egregious offenders, the biggest sources of pollutants in your home, then we're going to want to dilute the air in our home and replace it with fresh outdoor air that we filter, that we condition, and that is delivered to the rooms where we need it at the rates that we need it to allow us to breathe. And you can think of this almost like the home acting as an extension of our lungs. It needs to supply us with that fresh, good air so that our lungs have access to that fresh, good air. We certainly don't want to be fighting against the leaks and leakage points in our homes, doing it the other way around. And last on this list is filter, which we'll talk about later today. Jérémie has some good information on that. But once we have control of our ventilation strategies, there is a phenomenal opportunity to take that fresh air through high quality filters and make it even better than the outdoor air that we're bringing into the house. So let's dive right into it. I know that I've got only a piece of the time today, so we'll try and make sure we're leaving enough time for everyone else. This is not a new area of understanding. If you go back even to Benjamin Franklin, I love this quote. He said at one point, "I am certain that no air is so unwholesome as air in a closed room that has been often breathed and not often changed." So the buildup of stale air in our homes, just by us occupying them, is a big concern, and we're going to deal with that through ventilation. And the Canadian building codes understood this very early on. Back in the first National Building Code in 1941, which was primarily focused on structural safety, fire safety, and health, meaning don't let your house fall down, burn down, or kill you, there was a requirement in that early code that habitable rooms shall be provided with one or more windows opening directly on a street, yard, or court. That's a ventilation strategy. Now, it's not a mechanical ventilation strategy, but it was an early recognition that access to fresh air is critical if we're going to live inside of closed buildings. As time went on and we changed the way we build and we started to have access to better technology, we recognized in the later codes in the 90s that mechanical ventilation was an essential piece of this strategy, so that even if we closed the windows, we had some means of bringing the fresh air into the houses that we need. And so the code introduced the requirement for mechanical ventilation, which could be provided either through exhaust or supply or both as a balanced system. Along with mechanical ventilation, we started to understand that we have to also have a grasp on how much air we need, depending on the number of occupants that we're going to be delivering that air to. And there was a quick understanding, I think, that this was more tied to the number of people that you were serving than it was to the size of the space that you were serving, although there is certainly a connection there as well. And so the code contains tables like this that define your requirements for ventilation based on the number of bedrooms in the house that you're trying to serve, with bedrooms serving as a bit of a proxy for occupants or people that will be living in that home. Now, the rate of ventilation matters, not just for fresh air supply, but also for humidity control. And we'll come back to that idea in a few slides from now. So what are the pieces of equipment that we include in the definition of mechanical ventilation? There really are two camps here. We're going to subdivide it quite simply into this. The first is source control. These are fans that operate in a specific location to tackle that very high up removal of contaminants priority. So the range hood and bathroom fans are squarely in the category of source control, where they're going to remove either cooking contaminants or extra humidity from washrooms at the source, right at the point where they happen. And then the second category that matters is continuous capacity, the ability to operate a fan or ventilation system on a continuous basis to have a constant supply of fresh air for the occupants of the home. This is the lungs of the home piece. So on demand for source control, continuous for principal ventilation. And the image you see here is of an HRV or an ERV which is certainly something that we're understanding is more critical nowadays. Because these are pieces of equipment that you can buy, there are testing standards that regulate them. And any piece of equipment that is a part of a CHBA net zero home, towards net zero home reno, labeled product, and even best practices to choose products that have been tested to a Canadian standard. The two shown up on the screen here, we've got CSA Group, which defines the methodology, and the HVI website, which lists the tested equipment and their testing results. This gives us confidence that the HRVs and ERVs that we're buying and putting into our homes have the ability to operate in our Canadian climate. You can imagine that when we're talking about ventilating in the Northern Territories or even in the southern provinces as you get the colder winters, if you have an ERV that can't survive a freeze-thaw cycle in its core, then you're not going to be able to provide the fresh air to the home that you need. So have confidence in the test standards when you're looking for your pieces of equipment. Understand that they're available and they're for your benefit. Let's look inside an HRV or an ERV box and understand what that really looks like. This is one of the pieces of equipment in our homes that I think homeowners understand the least. They often see a box hanging in their basement with a plug that makes noise, and they've been told that they've got an energy efficient renovation or new build on their hand, and they think, well, I don't know what this does. If I unplug it, it will make less noise and save me electricity. That must be a good thing to do. We need to help people understand that these boxes are the lungs of the home, and their role is to both extract stale air from the house and get rid of it, and supply fresh air to the home to replace it in a balanced way, meaning, exhaust air out equals exhaust air in, so they're not generating pressure on either side. They add the extra benefit of heat recovery, or in the case of an ERV, heat and moisture recovery, to save us energy. We recognize that we're spending energy to have fresh air. We also want to save as much energy as we can in the process, and we can do that by stealing back some of the heat from the air that we're throwing out of the house through the exhaust and transferring that heat to the incoming fresh air so that we have less of a burden on our heating systems to make up for that introduction of cold air into the house. And that's done through a combination of fans and controls, but really the key piece here is the heat recovery core that you see in the center of this image, where the two pathways of air pass through a heat exchanger. They don't mix, but they have the ability to transfer their heat across the streams and influence the air coming into the home, warm it up before it comes into the furnace. It's in this core that the primary difference is between heat recovery ventilators, HRVs, and energy recovery ventilators, which are ERVs. Sometimes you may also hear them referred to as enthalpy recovery ventilation. The E could be interchangeable, but energy is a little bit easier to say and remember than enthalpy. So the key difference here is that an HRV will only transfer and recover the heat from the outgoing air. And any condensation that occurs as a result of that exchange of heat is drained away and discarded. An ERV actually transfers both heat and moisture in the core, sensible and latent transfer of energy. And that allows us to both recover heat from that outgoing air, but also recover some of the humidity to prevent over drying in our winter seasons, which is something that we're constantly fighting against in our Canadian winters in many locations across Canada. So how do you know which one is best for you? Well, you're going to start with a few basics. The house you're designing for will have a required amount of airflow based on those tables we looked at. So we need to make sure we select equipment that can serve that capacity, the demand for a certain amount of air. You're then going to have a debate about HRV or ERV. And I will say this debate has evolved. When ERVs first came on the scene, HRVs were fairly well entrenched, and there was a debate, is ERV an upgrade or not? I would say that in most locations across Canada, except for perhaps the warmest climate zones like Vancouver, ERVs have sort of risen to the top. An ERV core has more benefits than detractors, and the ability to maintain humidity is always something we're interested in, whether we're air conditioning or heating in the winter. And so ERVs are very frequently the default choice nowadays. I think there's good arguments for that. In the lower mainland and some of the warmer climate zones, it's not as critical because there are different environmental conditions that we're dealing with, but it certainly won't work against you in any meaningful way to consider one versus the other. My understanding is that from a price point, you're not looking at significant differences there as well. I might default to some of the project teams to verify that comment later on. You then have the ability to select for duct configurations to fit your space and your controls, as well as choosing high efficiency pieces of equipment. Higher efficiencies mean more energy saved as you ventilate. As an energy consuming process, we still want to look at how we can do that most efficiently. Once you have your piece of equipment, there are a few different ways to install it. I'm going to go through these quickly so we can get to a couple of the last topics before I hand it over. The first one is a simplified install, meaning that you're going to pull air from the return side of the furnace to exhaust, and you're going to supply the new fresh air back into the return air side later on in the ductwork before the furnace, so that you only have a limited number of ducts to deal with in the basement space. This is going to allow you to take advantage of existing ductwork in your home. In a renovation situation, this is often, it's called simplified because it's often the simplest one to achieve. The next level up from that would be to look at what's called a dedicated exhaust strategy or a dedicated return strategy, where you extend the exhaust side all the way to the contaminant point sources, where we were already serving them with bath fans, kitchen exhausts, etc. And you pull air directly from those spaces, but you supply it through the central ductwork again. And the third strategy is what's called a fully ducted solution, where you have dedicated ductwork for the ventilation system that both supplies and exhausts air. And this may be something that exists alongside central ductwork or in homes that don't have central ductwork. If you're dealing with baseboard heating solutions, radiant heating solutions, or older homes, sometimes a fully ducted solution, if you're going to that extent in renovation, you have access to run these ducts, can be a very elegant and high performance solution. We have a little video here, a little animation from construction instruction that I'll just hit play on that gives a bit of a visual of this. And you can see the solution that's shown on screen right now is a fully ducted solution. The red air is the air being extracted, the stale air being extracted from the various rooms in the home, coming into the ERV. And at the same time, fresh air being pulled in from outside at a much colder temperature is being crossed through that heat recovery core. And you can see that the step up there, that 30 degrees Fahrenheit indoor air was being bumped up to 60 degrees Fahrenheit air before it even reached the furnace. And so the step up that the furnace has to deal with is much smaller in that respect. You also see here that some of the moisture from that outgoing air is being captured and put back into the supply side, which means less load on our humidifiers or dehumidifiers, and overall a more stable interior environment from a relative humidity perspective. See if I can click past the rest of the slide here. There we go. So in general, the summary for ventilation, as I mentioned before, is first you have to build an airtight home. Airtightness is so critical. It's the reason it was the first webinar in this series of 5. You have to build tight because that's the only way that you get control of your indoor environment. Once you have control, then you need to ventilate right. You need to put a strategy in place that's going to be a combination of the windows in your home and your mechanical systems to provide continuous healthy ventilation that is balanced and that includes heat recovery. And this has been a requirement of code, not the balanced heat recovery part, but ventilation has been a piece of our code for over 30 years now. Now, these are critical components because they help us maintain that relative humidity piece. And as we ask ourselves, what is the right relative humidity, we sometimes find ourselves in conflict with, let's say, hardwood manufacturers that want us to run the inside of our houses like tropical jungles to prevent expansion and contraction. We know that that's not realistic, but the targets we're aiming for with relative humidity are about 50% in the summer and about 35% in the winter to help maintain both the people and the product in our homes. And there are many sources of humidity in our homes. And we know that if we don't exhaust from those sources, we can build up too much humidity. But if we overventilate, we can also extract too much of that humidity. And so the capacity of our ventilation systems is a key component or key part of that puzzle of solving for a balance of relative humidity and fresh air in the homes. So repeating ourselves a little bit here, first you want to build it tight. You want to extract excess moisture at the source. You want to use an ERV when you can to retain winter humidity in your product. And then you can use things like dehumidifiers for summer moisture control in places that are very high demand, difficult to control, like basements. A lot of people think that if you have to put a dehumidifier in your basement, that you've somehow failed at the building science. I'm going to try and flip your thinking there and say it can be a very important part of your building science solution to have dehumidification in a place that needs it, like a basement. In fact, some of the builders that I've worked with over the years started to gift home buyers with a dehumidifier with a nice red bow on it. And they say, please run this in your basement for the next 3 years while your new concrete, runs its course. Not a bad strategy at all. We talk about source control as a really key player in this. I want to touch on range hoods for a moment. Many of you have probably seen this move towards chef level range hoods that cover 6-burner stoves and ventilate at 1500 CFM. Think about trying to run a high extract fan in a super airtight house. What is it going to pull the air through as it's trying to push the air out, right? The challenge here is that if you have a really high powered range hood and you don't have a makeup air system, you are risking backdrafting of some appliances. We'll touch on that briefly. But really, you're going to prevent your fan from working the way it's supposed to. It can't exhaust 1500 CFM of air, cubic feet per minute of air, if it can't also pull in 1500 cubic feet per minute of air from somewhere else in your home. And if you're not controlling where that's coming in, then you're going to have annoying drafts and whistles, or it's just not going to work the way it needs to. We also have to be aware that in some older homes, when we're retrofitting and we're dealing potentially with older hot water tanks, older furnaces that have open combustion venting, that if we don't measure the depressurization caused by that range hood and the other fans in the house, we can actually work against those ventilation and backdraft them, which means that air, that the combustion air from the hot water tank would stop going up the flue and start coming into the basement, which could be a major health risk as well. So makeup air might be needed. I encourage you to look into this. Makeup air can also have heaters added to it so that it doesn't bring in cold air, or it can rely on your furnace as the source for that as well. Last thing we're going to touch on in the ventilation before I hand it off is radon. Radon and other soil gases are another one of the contaminants that we are highly concerned about in our homes. And radon has been on the public mind now for a number of years as the second leading cause of lung cancer after smoking. It's a colorless and odorless gas. You don't know if you have radon unless you test it, but many astute observers have asked the question, well, if we're ventilating and diluting and replacing air, are we taking care of radon at the same time automatically? And the answer is yes, but not by itself. Ventilation, I think, is observed now to be a very important piece of a radon control strategy, but not a freestanding piece. You're really going to be served best by sealing your foundation first. That's removing the source of the contaminant, right? Same order of priorities we've touched on before. Control the source, isolate it, then ventilate right. And a ventilation system that is properly balanced is key here. When I say balanced, I'm referring again to the flow of air in and out of the home has to be the same so that you're not generating pressure with your continuous solution. If you have an imbalanced solution and you generate negative pressure, you may actually draw radon into the home. So commissioning your equipment is key. Installers that install ventilators should be balancing and testing them and applying a label to the units that says this has been balanced at these flow rates so that you know that you can rely on it alongside your passive and active radon systems as a part of your radon control strategy. I'm going to skip over that summary slide. I want to highlight, before I hand it over to our next presenter, that the Net Zero program, as Lynn said, builds on this idea of net zero energy plus more, things that affect our health, things that affect our comfort. And so this indoor air quality checklist is now a core requirement of the Net Zero labeling program and includes 7 mandatory measures, many of which are best practices or requirements of a net zero home anyways, but an additional requirement to select 6 further measures that can be implemented into a home. And I'll leave this slide for you to revisit after the webinar to come back and see how straightforward many of these are, but highly impactful and very much worth paying attention to. So a reminder of what we talked about here today. When we're talking about improving indoor air quality, first thing we want to do is remove the source of our contaminants if we can. If we've done all we can there, we want to seal and isolate what remains. When we've done all we can there, the next step is to ventilate properly. And this is where we have the most control in the solutions that we're retrofitting into homes. And ventilating comes before filtration, but the two often work hand in hand as a part of the same system. I think the summary has been stated already, so this is for your own edification when you come back to this. The last one here, though, is a really important one to highlight. Net zero energy renovations or towards net zero reno home projects provide an excellent opportunity to implement some of this learning, to implement strategy, and to create healthier homes through the strategies that we improve on. And with that, I'm going to hand it over to you, Jérémie, to take us through the relationship between system sizing, especially as it comes to heat pumps that are on the tip of our tongues, and how that ties into indoor air quality.
I'm going to try to take over again, Lynn. Seems having trouble taking over the slides, Lynn. I'm not seeing the same thing as earlier.
Okay, no worries at all.
Well, we might
I've
just
got control for you.
You got control for me? Perfect.
Yeah.
Okay. I'm not seeing the slides anymore. I'm seeing your face, but
Oh.
I still see them, Jérémie. I think we're
okay.
Just that,
You're still still good. Okay. I'll go through it then. I'm not seeing it on the screen. I don't know what happened on my end. I have it on the side, so it should be okay. So thanks, Mark. So
I'll just
Mark,
shoot for you. At the top of your screen, there might be 2 tabs. If you see one that's
yeah, that's where it is.
you should be able to see that.
Yeah. Thank you. Okay.
thanks, Mark, because from my side, I can't see what. Yeah.
No, yeah, I don't know what happened there. It might be okay. No, we'll just keep going. Um, so I'm gonna take a look at, so Mark did a great introduction, and leading into filtration as a potential additional piece for indoor air quality. And I'm also gonna bring in the element of improving air quality through system sizing. So the concept of proper mechanical sizing is going to be important to achieve good air quality as well. So 3 major topics that we're going to be going through in the next 5 to 10 minutes. Adequate airflow through high MERV filter is going to be an important factor for indoor air quality. We're going to look into, I think the net zero program has some minimums there. There's certainly some best practices as well, but you won't get to maximize the effect of your filtration. You need to get the right airflow going through it. Sizing your system is going to be an important factor. Continuous air, improving thermal comfort, and the amount of filtration that you're getting through continuously running airflow through those filters is another important factor that I'll walk through. And how are we going to achieve that? Well, there's setting your controls is going to be something that's important, but as well having longer run times of equipment, so sizing your system properly is also influencing continuous air. And finally, controlling humidity as an important factor in controlling bacterial growth, virus, and other contaminants and health implications related to IAQ. And controlling humidity, if you don't have a dehumidifier, sizing your system is also going to be very important. So let's go to the next slide. So let's start with high MERV filters that's going to be able to deliver best results in terms of indoor air quality as we look at those mechanical systems outside of ventilation. There is a minimum in the net zero standard. So the table that Mark had just showed, one of the mandatory requirements is to have a minimum MERV 8 filter. If you get into higher MERV filtration, so MERV 11 to 13, you're actually getting into a bit of filtration off the bacteria. You're filtering off smoke. So you're really getting into filtering out, those smaller particles that are a bit harder to get with those higher MERV filters. So my suggestion is, move to a MERV 11 to 13 filter. It's going to get you the best result. But just having a filter alone is not going to get you there. You need tight fitting filters. So using a filter cabinet is very important here. You don't want the air to move around your filter. That's not very effective. You want the air to move through your filter. So making sure that you have a tight fitting filter using a filter cabinet is part of that retrofit design that you want to consider. You might have heard of HEPA filters as well. Essentially they move past the MERV 13. They're a higher efficiency filter to get into, better filtration of bacteria and viruses. As you move to higher MERV filtration, you tend to increase the pressure drop that the filter will cause in your system. So there is a bit of a limit of what your system can handle. So it's a watch out for it. You might be able to handle it with certain equipment, different size filtration. And if we move to the next slide, Lynn, essentially your filter might be limiting your airflow of your heating system. So you want to be careful. So I have a table here just to show you, what that can mean in terms of pressure drop. So we have different filter sizes. This is for a 4-inch pleated MERV 12 filter, and then as we walk down the rows, we have different airflows that are going through this filter. Let's take a look at, let's say we had an existing filter cabinet or filter slot that was a 20 by 20 opening. We're generating about 0.22 inches of water of pressure drop through that filter. Moving to a larger filter size, so a 20 by 25 opening, for example, can almost cut in half the pressure drop. So there are techniques to move to a higher MERV filter without influencing the pressure drop, but that might require having a larger opening, something to look into as design considerations. How do you know that you're going to run into this type of issue? Well, if you measure the airflow of your existing system, then you can plan for it. So I'm going to suggest that measuring the airflow and understanding the pressure drop in your existing ductwork is going to help you make those decisions. Do I need to move to a bigger opening? Will the equipment be able to handle the higher MERV filter? So those are some consideration. The next piece is on humidity. So we know that if you look at ASHRAE, they would recommend keep it between 40% and 60% relative humidity for healthy indoor air conditions. Mark had slightly different numbers. The winter it's harder to achieve those numbers, causes other issues. In the summer, it can probably be in the 50% plus or minus 5, like Mark had in his slides. The main consideration here is if you're too humid, then you're promoting bacterial growth. If you're too dry, then there's other health effects that it does promote bacterial growth, but you might also have dry mouth, dry nose, things like that you don't want the homeowner to have. So you don't want to be too dry either. But mostly in the summer time, what your sizing your equipment can do is that you can get good dehumidification without a dehumidifier if you have an air conditioner or a heat pump. But that requires properly sizing that equipment to the cooling loads. So we'll need to know the loads of your home to be able to do this. So sizing your system, I'm hoping that I've been able to convince you that sizing your system is important for indoor air quality. And there's a few best practices that you can apply today that can help you get there. The first one is we've just talked about sizing your equipment to the cooling loads, using CSA F280 to know the heat loss and heat gain, so the cooling and heating load of your house is a first step in any mechanical retrofit that you should undertake. And then the next piece is we've talked about making sure that you're not stressing your equipment with too much pressure by if you're moving to a higher filter MERV filter. So using CSA 750, which is a new standard that's out and it was just published this month, where we'll be able to look at um, we'll be able to look at residential ductwork and airflow in residential ductwork. And having numbers on airflow and pressure will enable you to adjust system selection. Maybe you pick a smaller heat pump or a smaller system, get a lower airflow requirements, or maybe you adjust some ductwork as part of the retrofit because you want to be able to accommodate more airflow and the filter size to accommodate that as well. So coming back into this will not only impact indoor air quality, but sizing systems also has implications around energy efficiency of your system, as well as providing better thermal comfort. So that the IEQ element that Mark had mentioned, and that's all I had. And I think Mark Bernhardt was gonna move on next.
And you made really good points there, Jérémie, where we've talked frequently about getting the right answer is part of the cost-effective strategy because money is being invested and it doesn't necessarily go to the right system. It goes to right components, but not necessarily the system. And you don't get the results that you hoped for that investment. So it's very key with that. And yes, we're going to turn over to Mark Bernhardt. And Mark, I think you can take over now.
Yeah. Yeah, thanks for that. And that comment about, the right system for the right solution in the right time and place really ties in well to the project that I came to talk about today, which was the LEEP 10 project and how ventilation worked within that and how it all sort of tied together. So for those that haven't had the pleasure of listening to the contractor talk about this yet, who was ThinkBright Homes, LEEP 10 was this sort of idea that ThinkBright cooked up and is a bit of a wild and crazy plan to gather as many rebate and incentive programs together and aggregate them all under sort of one roof and then do them all in some sort of streamlined way so you can economize on things like integrated design, having all the trades, there and familiar with the team so you're not sort of reinventing the team every time and sort of realizing a lot of efficiencies. And in the end, there was a fairly good chunk of change available for each house. I'm not exactly sure what the dollar value was, but it was pretty good. And they did manage to collect 10 homes for this project. All of them are in the Invermere area. And so for those that don't know Invermere, it is Alberta's cottage country, but the people that actually live there tend not to be high income generally, unless they're people that retired from Alberta in their cottage. But for the most part, they're it's not a high income area. These aren't rich people, and so most of the homes were people that weren't going to be able to afford a proper deep energy retrofit, and so they were really focusing on that towards net zero rather than the actual net zero. In fact, of these homes, of the 10 homes, only this one here, this white one with the shabby looking siding, is expected to actually get to net zero within the next 5 years. And one of the main reasons is because this house has shabby looking siding and it needs to come off. And you'll notice it's a very simple shape and a bit of a historic house as well. So there's lots of other justifications for keeping it up and doing that. In this, we did do a full day of IDP, which many of this team here was able to attend. And in that was really interesting. And what really ties us back to ventilation in a lot of ways is that we did a lot of math on these. We ran a lot of different scenarios and sort of aiming to create the plan, the net zero plan, and how do we get from where we are today into, potentially a net zero house and what we would, have to do in the 1 to 5 years, what we would have to do in the 5 years plus sort of thing, right? None of these homeowners had the money to say, oh, here's 200 grand. Let's do it, right now today. So it was all, what can we do today to get the biggest bang for our buck while not interfering with the solution down the road, and sort of, pick away at it over the years, and do it that way rather than, full meal deal it, which none of these homeowners could do. So we had plans for all of them, various different options to look at. Starting with a 50% reduction in emissions and energy. That was for one of the other programs that we were looking at, as well as going all the way to net zero. So all of them got a plan. And all of those plans went through a fairly significant optimization process. So that was our main role on this project, actually. So there's an energy advisor that is local to Invermere, and we have our closest team members in Nelson. So that energy advisor did the actual energy modeling and that sort of such, and then we took over the optimization and then the net zero sort of things, which they didn't have the capacity to do. So. We looked at, for each of these homes, hundreds to thousands of different options and how could we get it to net zero. So many of the homes sort of look like this, where, all the options got them better, and in some cases kind of just kissing that line. But some of these options way out here were not necessarily the practical ones, right? That starts to get kind of wingnutty solutions. And I believe in a couple of the cases, we could theoretically get it there, but nobody had a bank account big enough to realistically do it. So they were really focused on that towards net zero. And luckily we did get a few of them there with realistic scenarios and stuff. So good news on some of them. But one of the things, I guess I got an extra slide here that I've forgotten about. Look at that. Some of them did get across, and not too hard in that case. One of the things, though, that kept coming up again and again, and was a real issue in the IDP, and it's the first thing you notice when you walk into some of these houses, is that they had serious air quality issues. And it wasn't because the homeowners had like 1,000 dogs or they all smoked like crazy or anything like that. It was because the ventilation was poor or non-existent, and there was high humidity in most of the houses. And this is Invermere. This picture was taken in the summer. Invermere is not a high humidity place in the summer. It is very dry. In the winter, it is cold and rather inhospitable, in my opinion. That's why I don't live there. And so it's not known for being wet. So if you're in Victoria, where I live, and you got a wet house, well, relatively normal, pretty easy to figure out why. But in Invermere, if you've got a wet house, you've got a serious problem. So we were seeing mold. This is a picture of one of the houses there. You can see the mold on the window. You can see the water there, and also being in the interior of BC, smoke season is a very serious issue, and there is no filtration in any of these houses. So the air quality was very poor. And so for that reason, one of the things we really needed to do was start to look at, how could we improve that, right? Our hierarchy sort of changed. And so, unfortunately, though, with ventilation, when we were looking at the optimization, ventilation really didn't get us very far. And so looking at the options here, like the base case scenario was back there. If we put in a poor HRV, it got us there. If we put in a good HRV, it got us there. And, now, yes, it's better for sure, but it's not a game changer. It's certainly worth doing for many other reasons, but it is not going to get us there on the energy side of things. And that put us in a bit of an interesting situation where, the programs we were working with are really focused on energy, but this, very serious human health issue quickly became sort of the top issue. And when we look at our optimization priority, right, we started by focusing on energy. And then during that IDP really, decided that energy is important, but the cost is high and can be done over time. So this isn't necessarily something we need to do today. And unfortunately, the energy cost results are slow, right? And you'll notice the comfort results of the energy reduction, but, that'll be noticed by the homeowner, but, still the cost reductions and all that sort of stuff, that's slow. Which is annoying for energy nerds out there. I'd love it to be a lot faster and a lot more immediate and be like, yeah, let's go get that big insulation, right? Carbon is important as well. That was, one of the other things we spent a lot of time talking about. Now, here in Invermere, they do not have access to gas, to fossil gas. So there's a little bit of propane, but not a lot. It is relatively low carbon as far as the operational emissions, anyways. So we'd be looking at embodied carbon in many of these things, and that is something this particular builder does a lot of. So in our case, where they did use propane, like the fuel switching was an easy way to save money. A little bit of upfront cost, but unfortunately, minimal tangible results for the homeowner. Right? If their house was warm before, well, like, does switching to a different kind of warm really change the warm? And so for there's a cost savings, and we can do that, but the difference in warm to warm doesn't necessarily change much for them. But so that really led us to really the health aspects of it. And this became very motivating, I think, for many of the homeowners here, because the cost of this was relatively low and the results are fast and noticeable. And so in our hierarchy of needs, when we're doing this IDP, was that the air quality then moved to the top of the list. So energy actually started to take a little bit of a back seat, and it's quite different to many of the IDPs that we do, where that air quality is on the list for sure, but not necessarily the top. And so very, very significant change in sort of how we operated there, anyways, and changing that priority. But with low cost and relatively high impact in terms of what the homeowner is going to feel today, that was huge. And so all of the homes that had air quality issues have now almost all received their ventilation upgrades already. So I think there's 2 or 3 that are still in process, but that's how fast, right? And this happened in the summer, the IDP session. So they're quickly making these changes and seeing these results already. So hopefully in line for a better air quality style of winter. So ventilation options for this sort of stuff, and how was it done? Now, unfortunately, most of these places didn't have open crawl spaces. There was a number of houses that did, and so the open crawl space, easy. We can pop in a ventilation system, pop it up everywhere, no big deal. Kind of Bob's your uncle. Lots of different options on the table. Very easy to get a balanced ventilation system there as well. So we're not pulling moisture through the walls or pushing it out or what have you. But in many of these cases, so maybe we're slab on grade, or in a couple of cases where the interior condition of the house was actually pretty nice. Like, you're not going to go cut walls in like a pretty nice house. Some of them had, very nice fir siding or like, tongue and groove ceilings, that sort of thing. You're going to get fired before the homeowner lets you cut into that ceiling. And so the solutions were to use just through the wall HRVs. So now I've got a caution note that the through the wall, this particular one, this is the Lunos HRV, is not CSA certified. So when we're talking about towards net zero, this is maybe in the right direction, but this will not get you certified net zero. And so, I'm hopeful at some point these systems do get their CSA approval, but they currently do not have that. And so this would not qualify as a net zero ventilation system. But for a solution where I don't have easy access to the walls and I can't cut them all open, I can drill a 6-inch hole in the wall in 2 locations, and now I've got a ventilation system that will oscillate. These are how they work. One blows in, the other one extracts, and then they switch, and they do this kind of all day. And they're very quiet, and 15 amp circuit sort of thing. So for something that you can pop in quickly without destroying half the house, in my opinion, decent solution. The other option that was used was this Zedner unit, which is CSA approved. Unfortunately, not for any of you that live in a cold climate outside of Vancouver, but it would meet the net zero requirements within Vancouver area. I'm hopeful again that there'll be some more things like this soon on the market. But here again, it's a single 6-inch hole in the wall, relatively easy to pop on the wall without destroying the whole house in some sort of cost-effective manner. So And again, with relatively low power demands as well. And these are things that we would again go back and balance so that we're not seeing that depressurization or pressurization of the house. So we're not causing other problems. And one of the ways we're doing this, so our team does commission HRVs around the province and various other places as well. One of the ways we're most commonly seeing this done, and as sort of a quick check to see whether we've got it in terms of the balancing, is to have your energy advisor, when they're doing their blower door test, turn on the HRV and then turn it off and see if their dial changes. If it changes as a result of that, you're probably not balanced. And so very quick way to check and see if you are balanced, and someone you're going to have on site anyways, and takes all of 30 seconds to check it out and see. If you need something more sophisticated than that, there are people around that can do it, and that's something we do, but generally that's a good enough check to see that we do in fact have that. And that is where I will leave you, but with a quote from the builder in this case, who I'm not sure will appreciate me quoting her, but she says all sorts of profound things every now and then, so I'm going to do it anyways, which is, what we are doing isn't working and we need to do something different. And she couldn't be more right about that. She was, I think, speaking about the way we administer sort of funding programs and things like that. But, because we need to collect it all together and do something a little bigger and a little better. And I think that applies to the way we renovate, the way we retrofit as well. We need to think longer term. We need to think differently than the right now and the sort of immediate thing that I can touch and see right now in the shiny countertops. So that is where I will leave it, and I believe I'm passing it over to one of our builder team members now.
Yes, we're going to turn over to Michael Shaw, who's coming from Saskatoon. Centennial, hope the weather is not taking you out on that. And to your point, Mark, the doing better, what we've been doing isn't working. And I'm going to reiterate something I've said in other webinars. Canadians are spending over $100 billion a year on renovation, maintenance, and repair. So that investment is going out. We want to do better by it. And with that occupant first type of thinking, as well as occupant and envelope first type approach, there is that occupant level to do that. So Michael, I'm going to see if you're on screen. Let you pop up, and we can get you to take control, or I can switch the slides for you. We'll get your sound sorted out first.
Okay, I'm here. Can you hear me?
Awesome. Yes.
Perfect. Maybe I'll just get you to switch the slides for me because I don't see
Sounds
where I
good.
should take it over. Great.
Absolutely.
Well, I'm Michael Shaw. I'm from Centennial in Saskatoon. One side of our business is a renovating business, and the other side is plumbing, heating, and electrical residential service and installations. So I come from a renovation background, but also from a mechanical systems background. And we're pretty passionate about mechanical systems, so this kind of stuff gets us going. Anyways, we took on a crazy project. There's this beautiful 1956 mid-century home right on the river in Saskatoon, and we decided to chop it in half and add a story, and you'll see that there's an incredible amount of glazing and the views are beautiful, and this house is just going to be really incredible at the end of the day. The big challenge with the house to begin with was that it's on the river valley, but it's a raised bungalow and wasn't tall enough to have a good view over the trees across the way. So we decided to, do a very major renovation just to take advantage of that view. Now, renovating the house was our goal, more so than a net zero ready status goal. But I had just taken the net zero training and wanted to see what it would take to get it to net zero ready. And it's still to be determined whether we'll get there. We're hopeful that we will. But we've been having lots of fun with it and working closely with Sunridge Residential to try to get there. So the project priorities was to modernize the 1956 structure while retaining a lot of the mid-century charm that it has. The house was a little dark. It always felt and smelled musty, and really didn't feel like it had good airflow to begin with. So one of the goals also was to improve comfort, airflow, and definitely indoor air quality throughout the house. And as we were getting into the net zero process, we're realizing with such a tight envelope, air quality is going to be incredibly important. So we wanted to make sure that we really focused on indoor air quality. And the other side of our business does focus on some of that. So we're in luck there. Um, so what we ended up upgrading, we upgraded the entire envelope. For air tightness, we worked with Sunridge on their blower door test. We also have an aero seal process happening to seal up any minor leaking. That's just about to happen. So we're excited to see where our air tightness ratings come in after that. Installation was upgraded, all the windows, mechanical systems. We've added an ERV. We've got a few indoor air quality solutions that I'll talk about. And we changed all the interior and exterior finishes. So this was a very significant renovation. So the existing energy use in this house was very large, 447 gigajoules. Our predicted is 71, so huge difference there. And it's a bigger house now as well. So we really hope we can accomplish that. And yeah, that turns into an 84% energy reduction and a 64% greenhouse gas reduction. Probably in Saskatchewan, our grid is not clean enough to get that number lower, but I'm assuming that has something to do with it. I don't know that for sure. Obvious homeowner benefits from this is reduced energy bills from the indoor air quality upgrades that we do. It'll be a really great environment inside, and it'll feel really great. And they'll be living in a beautiful house with an incredible view. We had some challenges. We've had lots of challenges. Roof insulation on a flat, low slope roof was a challenge for us. We were trying to keep some of the existing polyiso that was there and tie in, but there was a mistake made. I'll talk to you about that a little later. Our mechanical system design, first of all, designing it in our cold climate with this many windows is always a challenge. Making sure that we can make the addition work without having to have a lot of really weird bulkheads and design elements that are going to get in the way was a real challenge. And then filtration without restricting airflow. We were crazy enough to try to save some of the ductwork that was there. And we did save some of the ductwork that was there. So static pressure definitely was something we have to be concerned about. So we didn't want to make that even worse. And obviously just with deep air tightness like we were predicting that we're going to have, just making sure that our air quality and the health of the home is good. That was a challenge for us. Anyways, we're predicting that it will work. We're predicting that we will hit net zero status, and all the good things that come along with that. So this is just a picture of the front elevation, just to show you how much glazing is on this house. They are triple pane, low E windows that seem to be performing decently well so far. But yeah, that's what we're dealing with. This is our existing ducting plan, and the red is what we demoed, and the black is what we didn't demo. So just showing you that we were really trying to keep as much as we can. We wanted to preserve the heritage of this house, but also when it comes to being friendly to the earth, wasting as few materials as we can is something we wanted to do. Would I do the same thing again? Probably not. But our mechanical engineer designed it to save as much as possible. So with the roofing issue, This is more of an envelope issue than an indoor air quality issue, but our demolition crew took off the original poly ISO that was supposed to remain. And you'll see in the first detail that we were supposed to add insulation that met up with the top of the existing insulation, and then we had some there was going to be some bridging problems with the 2-ply beam that went across that we attached to. And when they made that mistake of demoing the existing poly ISO, it was probably a little bit of a blessing for us because we were then able to have a continuous thermal barrier with new poly ISO on top. And so it ended up being 5 inches in most places and 5.5 inches of poly ISO on the ceiling without, any thermal bridging. This detail is not exactly correct. The one that I just did the little drawing over top, but I think that we are going to see better insulating values because of that. That's where the house is at right now. The exterior's come a little further than that, but we're getting really excited to get into finishing stage. What we're doing from an indoor air quality perspective, this is probably the stuff that's most exciting for us. So we are putting a duct mount HEPA air cleaner, and now this HEPA air cleaner has a booster on it. And so the static pressure drop that you might experience with a normal HEPA filter, we can boost the pressure up so we don't see that static pressure drop. And so this HEPA air cleaner has HEPA and UV built into it, is my understanding. And so that'll get attached to our main mechanical system. We also will have UV coils to prevent bacteria growth on the cooling heating coils that are on the air handlers. So that's kind of the main way that we're filtering air. We did radon testing to make sure there wasn't a radon problem. And so far, so good. We'll do more testing when the house is complete. From a humidity point of view, we will have a steam humidifier being installed. Saskatoon's a pretty hit or miss on whether you need to add humidity or get rid of it. Now, we do have some challenges in a mild summer where typically you would count on your air conditioner to remove moisture from your home. But if it's a really mild summer and you have a humid home, you don't really want to run your air conditioner all that much. In those cases, we would put in a dehumidifier. So it's yet to be seen if this house will need also a dehumidifier or not, or if we'll be able to manage humidity without. The infrared, or the picture on the right-hand side that has the number 3 on it, is just a picture of some of the air tightness challenges that we ran into on existing homes. So where the brick facade on the outside was tying in and we didn't insulate over top of that, and where the exterior walls met the floors, we are really having some challenges there. So we've added some more Acoustisteel, and we're hoping once the drywall really hits that Acoustisteel on there that it'll seal up a little bit better. Once the AeroSeal process is done, maybe if there's anything, minor leakage happening, that will take care of it. But we haven't seen if we've been able to solve that yet. So if anybody has any ideas for us, throw that out there for it. But anyways, this is our crazy project. I'm happy to answer any questions that anyone might have. But yeah, thanks for letting me present.
That's a gorgeous renovation, and it's really nice. We find that there's a lot of intent in our projects of preserving and complementing and adding to rather than taking away and starting new, right? So that's a wonderful view, and definitely will be a fantastic view over the river. So we'll hold the questions for now, and we'll have them after we move now to Luke Vandenbosch, from V+V Homes. And Luke, I'll let you take over, or I can, oh, there you go.
Yeah, I think I got it. Got the wheel now. Yeah, it's an impressive renovation you got underway there, Michael. The mechanicals alone are um, they're impressive for the mechanical nerds for sure. So here we go with our Richmond Street renovation, our addition in Thorndale. So, oh, did I lose control here? I still got it. Um, so this is just over a 50-year-old home, or approaching a 50-year-old home. We effectively doubled the square footage. We're in climate zone 5, so we do get those really hot, warm summers, but we also do face really cold winters too. So a large swing that we have to address. And we partnered with Homesalt Building Solutions. Jason Chang's also on the call if there's any technical details I can't answer. I've lost my control. There we go. Apologies if I'm lagging at all. My internet connection is spotty these days. So here's a before and after interior shot from approximately the same angle. So you can kind of get the sense from the before how this is sort of a dark, a dated bungalow with some interesting renovations over the years. So we tried to bring it back to that earlier. Maybe we're forcing mid-century a little bit here, but that was the design style for the client. Um, Moving on to project priorities. As you saw in that after photo, we have that sort of sawtooth roof detail and the clear story window. That was sort of goal number one with the project. Uh, that filters into natural light being in every room. So it was important that there's a window in every room. In most cases, the intent was to have at least two. The high performance and resiliency was also top of mind. So building something that's going to be that's going to last ultimately a forever home. To expand the living space, so again, we effectively doubled the square footage. Used as essentially the existing footprint as now the communal gathering space for living, dining, kitchen. To improve that indoor-outdoor relationship, as you saw in that previous before photo, the windows were small, the views were minimal. This is on a rural property, so no real issues of privacy, just an issue of not being able to see. And finally, being a sort of rural lot with a lot of similar homes in the area, keeping that neighborhood context without being too overbearing with a super modern home. Um, so some of the upgrades include vaulting the roof. We essentially reframed most of the living space. The vaulted roof then has a 3-inch R17 polyiso insulation applied outside of the building envelope. So outsolation, I call it. We have then R35 closed cell spray foam. The wall assemblies were reframed to a 2x6, and the exterior insulation being Zip R12. So we're getting the Zip R12 and then the R22 mineral wool in the 2x6 assembly. The foundations all got R10 XPS rigid foam, as well as the 2x4 mineral wool cavities on any of the framed exterior walls. And then an R12 XPS under slab. The natural gas furnace was replaced with a Mitsubishi 3-ton cold climate heat pump, which is still up and running, works great even the coldest or the hottest days of the year. It has a Life Breath ERV 170, which is 75% SRE efficiency. And finally, replaced the gas hot water tank with electric heat pump water heater. So effectively for heating and cooling, we are 100% electrified. So eliminating any combustion off gassing in the home as well. For some reason, my controls keep disappearing on me, but click back one. There we go. So before and after of the front facade, again, sort of maintaining the look and feel of the home. Now I'm lost. How far back do we go? That's a few too many clicks. This is probably my internet lagging on me, so bear with me for a moment. Keeping the neighborhood context, obviously we increased the views, the indoor-outdoor relationship. And I've had some of my colleagues comment on how the after photo looks to be AI. I want to assure you that this is a real photo. Just have a look at the landscaping just to prove that it's not 100% AI. One element of the increased window exposure, and one of the challenges as well, is this homeowner elected for two pane windows. That was a conscious decision early on. But we were able to kind of counteract some of the energy loss, heat gain, through natural shading or solar shading, as demonstrated in this photo here with this Brise Soleil shading device on the front facade. But having to do that, we certainly had to make up for it in other areas. So one of our main focuses was air tightness. We were able to achieve a 0.80 ACH post-construction. We sat at a 1.00, and I'm emphasizing the second zero. Again, these look fake. They're very round numbers, but I can assure you those are the actual tested numbers. We were able to achieve that through additional detailing. The zip system works really well, but and able to get down to that 1.0 pre drywall. We did perform a smoke test, and being that airtight, having 100% electrification was very important to us. This goes as far as the cooking appliance as well. So it's an induction top electric range. So there is no greenhouse gas emissions or combustion emissions within the home. Obviously, 100% energy reduction and greenhouse gas production by going full net zero. This was achieved by a solar array on the south-facing roof as well. So the benefits for the homeowner being the reduced energy bill, the thermal comfort year-round, the acoustic comfort. So that goes towards Mark's point about IEQ. So there's that environmental comfort as well as the air quality. But the one thing I wanted to point out is this home had a significantly oversized heating system for the 800 square feet that it was previous. And when the air system would kick on, you'd get that loud oil can bang. And then after a 10, 7, 15-minute cycle, the whole system would turn off. And you'd get the reverse bang of the duct system depressurizing. And then you'd have this deafening silence from having that background noise being removed. In addition to that acoustic comfort, there's stable humidity year round as well. And then just to let you know that ERV is sort of modulating that humidity. It works really well in the summer as well as in the winter. We set it to about 45 relative humidity with a minimum 10 minutes per hour. It does seem to work better when the house is occupied longer. Just using the manual switch to turn it on, etc., helps to recycle that fresh air. You can certainly notice it for being away from times. And again, zero greenhouse gas emissions. I'm seeing a note about the smoke test, so I'll get right into it. This is exactly what we mean here. So here's Jason using a dry ice machine, sort of like a pyrotechnic show. He's filling the basement. We've filled all of the floors, and then what we did is turn the blower door in the reverse, so it's positively pressurizing the home. So this is it inside, and we'll get into what's happening on the outside. So a few pinch points or points of loss. You can see on the left here, we're losing some air through the laminated LVL beams. So a lesson learned there, when you are laminating, apply acoustic seal or some sort of sealant at the air barrier plane. That would prevent something like that. We've got another one here where you can see we've probably flexion taped our windows, but we're losing smoke between the stacks of shims, which have not yet been caulked. So the window itself everywhere else is good, but we were able to isolate on the points where the window's resting. We're actually losing air through those points before applying interior caulking. The next one, which was a bit of a surprise, but makes a lot of sense. Again, harking back to Mark's note about sealing your sump pit. If it's a source of odor, then it's a source of air leakage or air loss. Let me back it up again here because these are interesting videos. One more. Apologies if this is my end, guys. One too many. Hopefully this plays, but essentially it's just showing this dry ice smoke billowing out of the weeping tile, which is tied into the sump pit. And if we can get this video to play, it's our team during the smoke test. Yeah, why don't you go ahead and take control if someone else can do that. So this is the most challenging detail of the project, but this is our clear story detail, and particularly where those roof components meet. We have those plan reading. That was a very difficult area to seal, and obviously we didn't do it as well as we probably should have pre drywall inspection. We did rely somewhat on closed cell foam to bridge that gap, but certainly if we were to do it again, we would improve that detail and bring that wall plane up right into the underside of the roof deck. So with that being said, let's move on to
And that smoke
some
test
of the
is
challenges, and
really,
we'll get into the detailing of this.
the smoke test is really informative, and
Yeah,
I
it really
agree
did
with you.
help us identify. Yeah.
Yeah.
We were also considering aero barrier or an aero seal, but when we were able to isolate and find those points of leakage, to move on and seal them up during the leak test. I think we had Jason on site for about 4 hours that day. We were able to isolate and seal most of those issues. So getting down to a 0.8 was good enough. So homeowner interference, the grand reveal here, I'm the homeowner and I was interfering quite a bit. I can see that from both perspectives, being the contractor and the homeowner. Certain things take priority. And again, having renovated a few of my own personal homes, for some reason you just think it's fine to break the rules on your own, but it ends up biting you every time. So the biggest one was electing early on to stick with double pane windows. What seemed like a big cost savings at the time, ultimately, I don't think it saved me anything. It's likely to cost me. It feels like one of the things that I'm already putting on the deferred maintenance list is to switch those out for triple panes in 10, 15, 20 years, whenever it is. And because of that, we had to really achieve those higher levels of performance in order to meet net zero. So, it forced us to be better in some ways, but ultimately, I think I would change that if I had the chance. I had an expedited IDP, so I essentially earned my net zero certification the day we started digging the foundation. So we didn't have as much runway to work through some of the detailing before we really got started. And then, of course, that sawtooth roof detailing, that was sort of goal number one when I started designing the home. Is the first one I'd ever done. So certainly things now that I've gone through it once would have changed and improved. The successes, however, so there is a window in every room. This achieves daylighting. It's sort of like a passive design principle. The comfort and quiet in every room. Again, I mentioned the duct bang, but in the old home, I used to hear the coyotes maybe 10, 15 nights of the year, hear them like a pack of hyenas, as though they're right outside my window. Now I don't hear them at all. I'll occasionally see my dog perk up and then listen very closely, and I can hear them. But yeah, it's a big difference maker. Cars going by, the whole thing. So we ultimately have like a resilient forever home. I plan on dying in this home. I incorporated some adaptive home principles. So that's another CHBA program, essentially about aging in place. It's not something I expect to need anytime soon, but it's one of those things that helps regardless. Sooner the better. Showing just an example of my walk-in shower here on the left. We did achieve that context in the neighborhood. We're not overbearing with some hyper modern home. The solar panels are obscured from view. And aside from the, trapezoid window, it does kind of tuck into the neighborhood. And we did win a local award with our London HBA for the interior living space. So I want to highlight that it was new or renovated. So we beat out the builders too. Moving on. So that's, again, an aerial photo from, I think, the early 80s, and then drone footage from post-construction. You can barely make out the solar array on the south side windows there, the south side of the roof. And you can see just the one roof penetration. I'll get into that. But, from the road, of course, it looks like a nice, beautiful new home, but it's not overbearing compared to the rest of the community. There we go. So cross section of the home showing the clear story roof, and zooming in on that clear story detail. I've highlighted the air barrier, the primary air layer. So that's the underside of our roof deck. So first layer on top of the framing, then our zip R12 carried through the plane of the window onto the zip R12, and then onto, again, that first layer of it's the zip system green sheathing, so the TNT sheathing, I think it's 9/32 or 9/16, sorry, 7/16, sorry. And then highlighting just the wall assembly itself. This was one thing that came out of the IDP, which was helpful, suggested by Stefan Magaran of HomeSol. But we have a 1 foot overlap of our exterior insulation before the foundation wall. This prohibits the thermal bridging from finding that weak spot. And again, air tightness was very important to us. It helped us achieve that rating. And one analogy I've heard and used many times since hearing it is, you can buy a really expensive Canada Goose jacket, but it doesn't work very well if the zipper's broken. So this just shows some of the exterior detailing for resiliency. We've got our large overhangs. We've got our 2 layers of strapping, so our vertical and horizontal, before applying our board and batten hardy boards. We have that drainage and drying happening without any restrictions. And then the roof assembly, just showing that in a little bit more detail. So again, our primary air barrier is this first layer of zip sheathing. Then we have our 3 inches of polyiso, followed by the zip roof sheathing, which is 1/32 or 1/16 thicker than the green board. And these are applied essentially in 2 layers, which are dried in, both of them taped and sealed, before we have the roofer applying his underlayment for either the 2-ply mod bit system on the flat roof or the standing seam system on the main roof. Oh, and one last thing. That is the one and only roof penetration we have. Everything else is vented out through the side walls, including, which I don't think you can see maybe from the aerial photo, the conduit for our solar array is done under the overhang of this clear story or our sawtooth roof section. So everything's protected from the elements. And that's it. I'll hand it back over.
Thank you. That's fantastic. And the informative part of the smoke test, I've heard, like, you're out in the country, but I've heard that if you're doing that in the city, warn your neighbors.
Yeah, that's a good
Just
yeah.
so you don't get any alerts going up. So before we break out into Q&A, we do ask, please take this QR code, please complete the survey. That helps us improve each webinar, not only throughout this Towards Net Zero Reno series, but also for all our webinars that we would produce in the future. So I'm just going to leave that up for a second or two more. And that feedback is also in that survey. We ask for what are your top 3 indoor air quality concerns that you're hearing from your clients, as well as 2 of your top challenges. So that is also really helpful for us in terms of guiding what's next in our education and training parts for that. So we are going to, I'm going to stop sharing, and that way we can dive into the Q&A. And Toby, you've got some questions that have been lined up.
Yes, I do, Lynn. Thank you very much. I'm going to go back and follow the order of the presentation. So we have a question for Mark Rosen. You mentioned HRVs would benefit from radon detectors. Do HRVs simply increase the volume of air to dilute, or are they intended to interlock with a radon gas system?
Yeah, great question. To add some clarity there, I think the slide really was indicating that if you are planning to depend heavily on your ventilation system as a part of your radon mitigation solution, then you would do well to have continuous monitoring of the radon levels in the home that a digital meter can provide to ensure that it is working as expected, so that you're not sort of underperforming and being unaware of underperforming. I'm not aware of any interconnected radon monitors and ventilation solutions that would, increase the ventilation rate in periods of higher radon. It seems like a good idea to me. Maybe they're out there and I just haven't seen them yet. But there is demand-controlled ventilation solutions related to other indoor air quality contaminants like carbon dioxide levels or others that can actually trigger higher ventilation rates to respond to an interior air quality issue. And a similar solution would probably work for a radon solution. But really that slide was meant to say you should be paying attention to help ensure that if your ventilation solution alone is not able to keep up with the infiltration of radon into the home, that you would want to look at pairing it with a passive or an active system as well. I would suggest for anyone who has the opportunity to introduce, let's say, a passive radon system prep, that's always worth doing so that it's easier to retrofit a solution if you find you need it, as opposed to depending at the project planning stage. This goes back to why an IDP process is so important. At the project planning stage, if you decide you're going to rely on your ventilation to control radon, and then you get to the inhabitation phase and you can't achieve it, retrofitting the radon solution is much more challenging if you haven't taken the steps to do a prep when you were in the midst of the renovation. So long-winded way of saying the emphasis here is that ventilation is a component of a good radon strategy, full stop. But if it's your primary solution, monitoring is recommended.
Thanks, Mark. There were a number of questions about the approval of these through-the-wall HRV systems. So Mark Bernhardt did answer a number of them. I'd like to give him maybe a chance to summarize that, and if anyone else. The questions were about, do they meet code in Ontario? How are they being sold if they don't have HVI or CSA approval? Questions like that.
Yeah, no, really good questions. And I think I should be really clear there is that if you have the opportunity to do a properly ducted full house ventilation system, that would be the way to go. Like, absolutely. Like, that's number one. If you're building a new house, obviously full house ventilation system, that is number one, the way to go. The only context I would recommend these is where you are trapped. and where for whatever reason you can't rip open all your walls, you don't have access to something, that is where these things are for. So this is not something that I would encourage, people to start, popping in their house all over the place, or just as a cheap, easy solution. This is a solution for when you're trapped, in which in that LEEP 10 case, we were trapped in a number of those cases. And so that's where they apply. Now, there are other certifications other than CSA that allow you to sell things in Canada. So they become like UL certification, for example, then it becomes legal to sell. But to be clear, most of them are not certified to be net zero projects. So they don't have that CSA approval or the cold weather rating either. And so this isn't something that's going to get you to net zero. It's going to be something that's going to get you out of a moisture problem that is a very serious and immediate health problem when you're trapped.
Thanks, Mark.
I wanted to jump in and add as well. I think thanks to Maxime Saval from NRCan put a good message in the chat pointing out that the HVI testing is a US-based testing standard. And what it does is it includes the temperatures at which the equipment is tested. NRCan has gone the extra step, and they maintain a Canadian equipment listing that points to the equipment that has been tested at the -25 testing point to be sure that it's ready for Canadian climate. So for Canadian-based programs, that list is really a good reference, a good source to have confirmation.
And it's relatively easy for builders to search as well, too. The interface for it has greatly improved over the last 6 months, and you can search by what type of machine are you looking for, including heat pumps and all sorts of stuff, the size you need, and the efficiency ratings and stuff. So it's become much easier. It's not just a sort of a back database that energy modelers use anymore.
Questions about ERV, 3 questions kind of about ERV sizing and how they work. So I don't know if there's any designers on here or anyone familiar enough with that. Maybe I'll leave that one second. The first question, just about how to run your ERV. Is it recommended to run it continuously? And then also just how they work. How can it control humidity if it's also recovering moisture?
Right. I saw Mark nod vigorously as well. Continuously is recommended. They're intended to be a continuous ventilation system. If you try to do it manually and turn it on when you think you need it, inevitably you forget to do it at times you really do. So it's really recommended to set it and forget it. I do want to clarify, it's a really good question about how do you control humidity if you are recovering humidity. And there's a nuance there that I think is important to understand. What an ERV allows you to do is to help maintain the level of humidity that you are influencing through other means. So rather than it being a control strategy, it's a maintenance strategy. For example, if in the summertime you're running your air conditioner, and there was a really good comment in here, but air conditioners can dehumidify the air both while they're cooling it or just in dehumidification mode as a dehumidification piece of equipment. You're spending energy to dehumidify the air. The ERV is going to help to maintain that instead of working against you by bringing in new humidity from the outdoor air. So when you think of humidities and ERVs, think of them as a maintenance piece of equipment as opposed to an influencing piece of equipment. I think that'll clarify that.
I would add to that too. If you believe any of the online forums, you'll see a raging debate about whether ERVs or HRVs are the best solution. And my opinion on this is, if in a renovation context, in a new house context, we could maybe have that debate, but in a renovation context, some ventilation as opposed to no ventilation is going to be significantly better than where you started. So whether it's an ERV or an HRV, you're splitting hairs at that point. And often in our case, the reason we go with an ERV is because it doesn't have a drain, and we're putting this machine in a place that doesn't have easy access to a drain. And so we can save a little bit of in-house damage by not having a drain. But generally, wet places like here in Victoria, we'd go HRV if we had the choice, ERV in drier locations where we want to preserve that moisture generally. But you can't, or at least the way the physics of it work, you can't over moisture. You're not going to make it worse by putting an ERV in. So there's low risk to choosing wrong. It's really just to get a good ventilation system in there as soon as you can.
I'll just add into the running continuously question that sometimes there are controls available that allow you, more than just on off. There's 20 minutes on an hour, 40 minutes on, some humidistat ones. And so sometimes running continuously may not work for certain occupants, and they may need to have a control system like that. Whatever works best for them, ultimately, I think is the best.
I'll say as well on that subject, I think it's a good point to make that many of the units that are tested and run in Canada have what's called a defrost cycle to preserve that heat core during the winter months. So even if your control is set to continuous, in the coldest months of the year, you may have intermittent ventilation where your ventilator will supply air for 20 minutes, and then it will actually recirculate air from inside the house for 20 minutes to keep that core from freezing. And so it's working invisibly in this on-off supply. And again, that's just happening. It's not a concern. It's just something to be aware of.
That's a good point. And that also relates to equipment that's not tested at minus 25 Celsius. It may not have those kind of functionalities. That's
right. Yeah, there's some interesting strategies, and there's controversy. I think the passive house world has had this debate about listed equipment for a while. Some ERVs, HRVs, instead of using a defrost mode that's recirculating, will add electricity, like an electric preheat, to condition the air that's coming into the unit, which allows, it's this trade-off discussion again about what are your priorities. That solution allows for more continuous supply of fresh air in cold months at the cost of energy. So are you producing energy? Does that energy have greenhouse gas emissions? What are your other project priorities? That's a discussion that happens at an IDP, right? That's where you start to make these directional decisions out of the gates. And so there are multiple ways of solving for that, something to be aware of. And it was only recently that I think some of the testing started to account for that additional energy use that came to bear. That's why you might see very different results in the efficiency rating of a piece of equipment if you look at the HVI test standard versus some of the European testing standards that don't include the energy for that preheat, whereas the HVI testing does. So something to highlight there.
Is there anyone that would like to comment on sizing of ERVs? There's a very specific question. Is a maximum 170 CFM rated ERV sufficient for a full house given frictional losses in ducts? Is there a typical CFM, ERV, CFM oversizing amount versus the designed?
This is an easy question because we can say no. The size of the HRV needs to be designed in accordance with the house. So if somebody says, "Oh, well, just like what should I use?" I'm like, "Well, I don't know. Like, how big is your house? How many rooms you got? What are you doing with that house? How many dogs do you have? All these different things." So the standard we size and design to is the F326 standard, which is another CSA standard for those that love CSA standards, and that will dictate the size of the unit within your house. For very high performance houses, when we are designing for those, we will typically design to run the HRV at about 50% capacity, which is a vast oversizing by many standards. But the reason we do that is because very high performance HRVs tend to have their best efficiency at about 50%. And then it gives us the opportunity to have a smelly, smoky, stinky day in the house and push the boost button and blow out that house with the jet engine when we need it.
Thank you, Mark. That's a very good answer. I think we have time for one more question. Lynn? Yeah,
absolutely. Yep.
Maybe I'll try this simpler one here. Is there a Canadian list for HRVs or ERVs that anyone's aware of?
That would be that searchable product database that NRCan hosts that Maxime put into the chat. And he put a link in the chat. So if you missed that,
great.
Just scroll up in the chat a little ways and you'll find that product. So thanks again, Maxime, for posting that.
And actually, we should add that into our resources page. So we'll grab that out of the chat and add that in. So, yeah. One of the questions that had come up from our webinar development was the ask of Luke and Jason, but also all the speakers here is, what is the simplest change that you know of or that you have implemented that has impacted the fresh air in the home?
Mm.
I would say air tightness.
Simply not putting
It's a
in the
complex system,
source.
but yeah, it's it has a big impact. And if it's done properly, it works well. If it's done improperly, then you pay guys like me to rip out windows and replace them. So things like that. Sorry, go ahead, Jason.
Oh, no, sorry. Just not including the source of the pollutant
Mm.
to begin with. Like Luke didn't put in any carpeting. And then when it came to paints, he chose low to no VOC paints as well.
Mm-hmm.
Each factor comes in. I think that's, the build it tight, design it right type of thing, where a lot of the emphasis on these projects has been like the funding from this towards net zero reno has been absolutely weighted on that design side, and then the checks and balances throughout the construction. So that aspect of bringing ventilation. But what we've heard, and this is also open to anybody's comment, is one of the things that has come up is, do homeowners know that they can ask for improved air quality? Because when you have the conversation with them, they go, well, of course I want that.
Yeah.
But how much does that come up when, as a renovator and even as an energy advisor, as that overwhelming energy discussion to go, I didn't even know I could ask for better indoor air quality. How do you navigate that?
Yeah, there's a great point. And even the simple things that are low-hanging fruit that people start to learn about through the process, like how do you use your controls properly for the systems that you do end up with? I really like that we got that piece from Jérémie today about filtration, because many homeowners don't understand that mode on your thermostat, which is on but not heating, right? Why would you blow air through your house when you're not heating or cooling? And it's so that you can filter the air. It's going to use your furnace filter at all times to improve your air quality as a side effect of having that central duct work and that continuously operating fan. So I really like the idea of asking the questions early on, helping the homeowners to ask the questions, but then also helping them to understand when they've been given a home that's set up for them to operate properly, how do they do that? And this is where I think we can sometimes overcomplicate the issue and say, well, you can turn this on and you can turn this off and you can manage this. Something like a central ventilation system that's properly balanced and installed should just be on. And then when it's on, you don't have to think about it anymore. And really, when it comes down to, we do want to do our best always to save energy, but the cost impact and the energy impact of running a good HRV for the 2 weeks that you're away on vacation is probably not worth spreading about when it comes to the flip side, which is forgetting to turn it back on when you're home with your family and affecting the indoor air quality of your home. So I'm
Or you're
always an advocate.
breathing in somebody
Yeah.
else's air, right?
I always like to advocate for systems that become dumb because they're so simple. Once it's going and it's running, you're good. Just leave it at that.
All right. So I'm just going to start with the closeout. But as I do, any final comments from our speakers?
Also, what
Is that-
Mark had just said there on controls and homeowner education, very key, both on the setting up the heating and cooling system piece, but also on the HRV, making sure that they're aware of what the equipment's doing, keeping it as simple as possible for them, and making sure the equipment's going to be running in the right way moving forward is the key goal. So making sure you're educating them on that front.
Yeah, totally agree. It's really critical. And one of the ways we help them do that is by giving it to them in bite-sized pieces. So we don't train them how to use the whole house in one day, because a person can learn maybe 10% of it in one day. And so every time they come for a site visit, this is the HRV. This is what this piece of it does. Then the next day, this is what this piece of it does. Or it's these small bite-sized pieces so they can learn over time rather than trying to cram it all down in one day when we give them the keys at the same time.
That's
Right.
such a great point. I know that in the new housing world, we run into that issue where builders, are delivering the keys and homeowners are excited. And the same is true in a renovation. That day you're moving in, you're excited. Probably not as excited about the HRV as you are about the new kitchen you've got or the new windows you've got or something like that. And we've heard from new builders that the 30-day service call is a great time to talk nuts and bolts about how things actually work. And I think the same can be said of a renovation, a follow-up visit after the cool-off period of excitement. More might land and stick with the homeowners.
Or you can actually retain what's coming in because you just want your house back, especially on a renovation, right? You just want your house back and you just want to go through there. So part of the reason why we do emphasize the radon testing, it is the winter season. It is an ideal time. There's a November campaign for it, but December is just as good. So get those radon kits in there and take advantage of that closed winter season. There's lots of resources there. We do emphasize it because it is one of those indoor air quality, environmental quality aspects. You cannot see, you cannot smell. So it doesn't have that nice indication. So we will be adding those extra links that came up into our resources. There's a whole, we'll scrunch it, we'll get more in there, and we'll make sure that everybody has that when the decks go out. And to close off, I want to thank all of our speakers. Thank you so much. You bring such a wealth of experience, knowledge, the feet on the ground, how it's actually happening, what's making a difference, and even the frankness of, I did that, would not do that again. This is the better path, and really excited to see the results of all of these projects. So hopefully you'll have a fantastic holiday season, and we will see you at our next session, January 14th, where we get into another challenging aspect of retrofitting your windows and making sure that that complements your design and your results and fully gives you those views that are really critical and wanted by your clients. So thank you again, and Happy New Year.